Hi everyone, following series that talk about ESP8266. Today I'm going to talk a little bit about how to create your own temperature sensor based on a thermistor. So the schema that we are going to implement will be the next one that you have in the screen now. Here we have in the middle the ESP8266. So in the pin A0, so the analog input pin, we will create a tension divider with a resistor of 10K and a thermistor that we will see in a few minutes. We will connect the power of 3.3 volts directly on top of that divider, and of course the other part will be connected to ground. So we are going to give 5 volts and ground for power to the ESP8266, sorry. And then in digital port 0, pin 0 and digital pin 1, we will connect just a simple resistor and LED emitters, but don't worry about that. It's just some control part that we are not going to use so much in this example. In my schema, I also have some pins for debugging, so the serial console is available through those 3 pins, or better, it's a TTL debugging connector. We are going to use a really small power supply unit called Highlink. It converts, of course, from 220 volts to an alternate current to 5 volts on continuous current. And that schema, it's going to be something like that. Here we have the power supply unit with the plug connector. Okay, and from the other side, here we have a current voltage that give power to the ESP8266 that we have here, and the voltage divider, it's in this part. And here we have the thermistor that changes the resistance depending on the temperature of the environment, and the 2 control LEDs that I described in D0 and D1 pins. And here we have the debugging connector. So if we take a look in a little bit more detail, here we have the front of the circuit and the back of the circuit. Here you have the PSU current voltage directly connected to the proper pins in the ESP8266. Okay, here is the idea, and let me go to take a look to the code for that. But before going to the code, some information about the components. I'm going to start for the PSU because it's very simple. So as you can see, I went to AliExpress. Here you have the short URL where you have that part in AliExpress. The cost of the part is really or extremely cheap, I can say. And here's some specs about that part. As you can see, it's nothing incredible, but for that price, it's really good part, really cheap, and more than enough for a circuit like that. Paying a little bit of attention about the thermistor here, as you can see, 5 pieces cost not much more than €2, so it's about 46 cents per piece, so extremely cheap again. And here we have the specs, the features of that thermistor and the resistance depending on the temperature of the thermistor. The table of equivalences. This is very important information because we will see that it's going to be used to calculate the temperature of the system. If you don't have any experience programming thermistors using Arduino IDE or Arduino code, Adafruit has a very good page where they describe how to approach to work on that. Here you have some information about how to get the analog voltage reading the analog pin. Here you can see that the schema is exactly the same with the same resistances used, etc. And here you have some examples about getting the millivolts value of the tension divider used in that example. So to improve those readings, they suggest to iterate several readings and later do the average of the measures that we get in those several readings. And in the end, we have to convert those readings to temperature, so those millivolts readings to Celsius degrees to get the temperature. So here we have the formulas that we have to apply to get that information and a simple piece of code based on regular Arduino about how to get that. What I did in this case, in my code, is just integrate those algorithms to use HOMI. So here we have the include of the HOMI library in our Arduino IDE. In this case, let me show you that. It's the Arduino 1.6.11, okay, with proper libraries installed. Let me see if they are visible here. Manage libraries, and here we can see, okay, the proper libraries. Installed. Okay, the Adafruit ESP8266, the MQTT library, so other requirements to run HOMI in our sketch. Okay, so let me go to the code again, and here we have some constants that we have to define to work with the schema. The first one is in which pin we have connected the thermistor. Remember, this is in the middle of the voltage divider, which is the resistance at 25 degrees of the thermistor. It's 10K. If we come back to the specs, here we have, where is it? We cannot, here it is. The resistor here, it's 10K. Okay. So the nominal temperature, as we assume here, for the resistance is 25, so it's 10K at 25 degrees. If I go to the table, I can see for a temperature of 25 degrees, I have 10K. They use an extra zero at the end, but this is just for precision. It doesn't affect in terms of the meaning of the reading of the information. Here we define the number of samples that we are going to read, and later we are going to calculate the average to get the reading. So it means we are going to take the reading 5 times, and later we are going to divide by 5 to get the average reading. Here we have to define the beta coefficient. It's also in the specs. Here we have the beta coefficient of the NTC. Okay. And at the same time, what's the value of the other resistor that we have in the voltage divider. If we come back to the initial schema, which is here, we can see that we use a 10K resistance here. So here it is. We define 3 or 4 global variables. The first one is the sample readings. The next one, it's the interval between readings. So we are going to read every 30 seconds. We're going to get the temperature and push that temperature to the MQTT server. Okay. Last temperature sent, so an historical information about the last reading. By default, it's 0. And here we define the node in HOMI. So we are going to use a node called temperature with type temperature. We can say whatever we want as a type. Here we can say, for example, Celsius or whatever. But later we define in the setup handler, we can say here a property of the node. Here we have temperature node, so a property of that node, which is going to be the unit with the value C. Okay. Let me go first of all to the regular setup and loop functions, and later we will see what's those handlers that we have before. So when we create some code in HOMI, as I defined it in my previous video about HOMI de facto standard, I have to declare, or I have to assume some default behavior. So to get that configured, the first thing that we do is just enable the logging. So it means in the serial port, we will have some information about what's happening with the system. We redefine the LED pin to inform about the status of the HOMI. If you take a look in the documentation, you'll see how, depending on the blinking speed of the LED, you'll have some information about if it's Wi-Fi connected, if it's trying to connect to the MQTT server or things like that. Later, we define the brand. It's InvHQ, so this is the base URL. Remember, by default, HOMI established that as a value of devices. In my case, I'm going to use InvHQ as my base string. Okay, and here we define the name of the firmware. I define that name, ESP8266-plug-temp in version 1.0.0. Okay, later I register the node. Okay, it will send some initial information about the node, just plugging in the node. Then we define a setup handler function and a loop function. So we are not going to use only that setup function, we are going to use also this setup handler. If we come back here, this is the setup handler that I explained before. And here we can see how loop handler is also declared. We will see that later. This is defined, the loop handler for HOMI. And here it's, let me say, a HOMI initializer after defining some properties as we did before in previous lines from 76 to 82. So in these lines, some values are set, and later we initialize the system with that command. Then, as you know, Arduino goes into the loop sentence. Here we only have to say follow the HOMI loop, and the function that to be called as the loop handler in HOMI is that one, loop handler. If we go here, we have the loop handler. The first thing that we do here is just control if we spend 30 seconds before a previous published temperature in the MQTT server. So that loop will be iterating again and again and again, and it's only going to be executed the next algorithm when that if sentence, so when 30 seconds has been spent, or when last temperature is equal to 0. So this is the first time that we run the system. We initialize two variables here. The first one is just an unsigned integer of 8 bits, where we are going to control the iterations, and float average, it's just a constant where we are going to store the average value calculated after reading 5 times the analog thermistor pin. So here we have the loop to read those samples 5 times. This is very easy. And after reading that, here we have how we calculate the average. First of all, what we do is very simple. It's just sum all the values that we get, and later we divide by the number of samples. Okay, so in the end we get the average. Here we print that to the serial console just for debug purposes. We can disable that constant that we have here, enable logging to. We can say false to disable logging to the serial console when everything is stable. I recommend that. Later, I apply. This is the algorithm that applies that formula. Okay, the formula that converts volts to Celsius degrees or degrees Celsius. I don't know. Here we have the temperature calculated, and we print that in the serial console. And in the end, this is the key to publish the information to the MQTT server. So thanks to that line, to line number 67, every time that we get that new reading, we publish that to the MQTT server. So later we keep on working on the iteration and evaluating if another 30 seconds are spent before sending the temperature again. So the schema to check that, the schema that I'm going to use to check that, it's going to be very simple. I'm going to have an access point that connects to internet. Okay, in this case we are not going to use that, but it's just for your information. Here you have the SSD where we are going to connect, and here it is the IP address of that AP. Again, here we have a chip, and this is a Raspberry Pi-like single board computer, where we are going to run Mosquito as an MQTT server. And so that ESP8266, this is the system that we are going to try, will receive a DHP address defined here, and using that ID and that node, it is going to publish the temperature readings to the MQTT server. Okay. To demonstrate that, what I am going to do, it's very simple. It's just connect to that chip and subscribe to the topic with the base and the ID of the device. Later, any information that has been published will be received. Just running that, I can see here the device is online. Here are the nodes that are declared inside the system, the name of the device, the local IP address received from the DHCP server, the firmware name, maybe you remember the name, the version, the temperature units, the temperature degrees, the signal level, and the uptime information. And again, because we spent 30 seconds just talking about that, we received another reading about the environment temperature. If we wait for another 30 seconds, we will receive another reading. And periodically, we are going to receive some uptime information just to inform the server that everything runs okay. Here we have the reading again, published. Okay, I only missed to describe something very interesting. As you can imagine, to run that code, the only thing that I have to do, let me minimize that a little bit to fit to the screen. Okay. For example, just connecting the device and clicking that button, the code will be compiled and pushed or burned to the firmware of the ESP8266. No secret. Previously, I have to define the port where I have that connected. For a while, in that instant, I don't have anything connected here. And here I have to select which kind of device, which kind of ESP8266 port I'm going to connect, because depending on the multiple flavors that we have about that chip, the code will be compiled in one way or another. As I said, I missed something to explain. Just after recording that, the device is going to get in a mode called configuration mode. If after doing that, we will see that a new AP is present in the electric space. So you can see electromagnetic space. You can see a new access point called ESP dash and some numbers and letters. Okay, some characters. You have to connect to that access point. That access point is published, of course, from ESP8266, which is pending to receive initial configuration file to know how to connect to the Wi-Fi network or things like that. So we have to connect to that IP, and it's going to give an IP address to our laptop. So let me describe that. The IP address of the ESP will be that 192.168.1.1, and your laptop or your desktop are going to receive that IP address. So the same, but ended with 100. Okay, your laptop, for example. Okay, so from that laptop, you have to run something like that. So you have to put in that URL, remember this is the IP address of the ESP8266. In that URL, you have to push using here that explains it's going to be pushed an application JSON content, the content of your config.json file. Your config.json file, let me open that file just to demonstrate how to create it. Sorry, here it is, documents here. Sorry, what is Arduino? Here we have Arduino, homey, temperature, data, and here I have my config.json file. In this case, you'll see here is the description of the device ID, the SSID of my experimental network, the password to connect to that experimental network, okay, just for demo purposes, the MQTT server information. Here you have the information, the base topic, blah, 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 all the information that you need. In this case, you can forget about that, or that if you don't use that. You can, this is by default false, so you can remove that if you want. This information about the over-the-air update, if you are not going to use that, you can say here false and just remove that part. Remember to be syntax correctly, and some settings about the coverage or the quality of the signal of the connection. So in this case, what I say is don't work as a non-configured device, because here you have your configuration. Work in infrastructure mode and connect to that SSID. And when you are connected, just reach the MQTT server with which you are going to work. Okay, mainly this is the information that we send using that config.json file. And the way to push that, for example, using curl command, is that way. Of course, you can push that in many more ways. Okay, so after that, as I said, you are going to see things like that. Okay, this is mainly my explanation about how to code a simple temperature sensor using Thermistor and ESP8266 and directly pluggable to the regular electric power. So using a power supply unit. I hope it's useful to understand how to start coding with that. See you soon.